Well, then that means that we're picking up today on number 7 of our 2-8 notes. This looks different. It's a rational function, and we were dealing with polynomial functions before that. That being said, it's very similar. So this, when we were doing polynomial problems like the ones above, for polynomial problems, we cared about finding the x-intercepts or the zeros. And something happened at the zeros. I think I even talked about it with your class, calling it the point of interest. It's interesting because it either like is where we switch from being negative to positive, or it all stays positive, but like something interesting can happen at my zeros. When we're looking at a rational function, we're still looking at our x-intercepts. We're still seeing where we cross our x-axis, but another like point of interest or something that we care about is our vertical asymptote. So we're doing the exact same thing over here, but the biggest thing is I need to keep it as a fraction so I can look at the vertical asymptote eventually. What we see when we look at this is we're like, oh, we'll clear out the denominator like we're used to. The only reason it doesn't work is because I want an interval. I don't want equals to. I don't want actually where it is 0. I want to know like where is it less than and where is it greater than. So we have to respect that denominator here. We have to respect him and keep him there because that's going to help me with my vertical asymptote. So in order to solve this, we need to move everything to one side and get it all in one fraction. So a lot of the first couple of steps are not even pre-calc steps. They're like algebra 1 steps. So I've got x plus 1 over x minus 3 is less than 4. So the first thing I want to do is minus that 4 over here. So I've got x plus 1 over x minus 3 minus 4 is less than 0. Okay, easy stuff. Now, like I said, we were tempted to clear out the denominator, but we are not allowed to do that. What we want to do instead is form these two pieces into one big fraction. So I'm going to multiply by x minus 3 over x minus 3 to the 4 in order to get common denominators. This is the same thing as like 4 over 1. So I'm going to do 1 times x minus 3, which keeps me at an x minus 3 in the denominator. But again, like we remember from even like middle school math, when we get common denominators, what you do on top is what you also have to do on bottom. That does not change that x minus 1 to the left, but it does affect this minus 4 because I now have it times x minus 3. Once we've done this, and some of you might have already taken it this step further, is I'm going to distribute that negative 4 through. So I've got x plus 1 minus 4x plus 12 over x minus 3. And then last step is I want to combine like terms. So I've got x and negative 4x. That gives me negative 3x. And then I have 1 and 12, which make 13, all still over x minus 3. Okay, so far everything I've done has been like an algebra skill that we've known before. It looks a little bit more complicated because we're keeping these big fractions. We've got exponents, we've got expressions, but at the end of the day, we haven't done anything new yet. That's coming. So now that we've gotten to this point, we've gotten it as simple as we can on both top and bottom. Now we want to identify the x-intercept and my vertical asymptote. Remember, we find my x-intercept of a radical or rational function by looking at the numerator. Sorry, that was really hard for a second. You look at the numerator. So we set the numerator equal to 0. So we do negative 3x plus 13 equals 0 because that tells me what my x-intercept is. Remember, we did that back in 2.6. We've got notes on that in 2.6. It's going to be a fraction, but that's okay. Minus 13 from both sides. I get negative 3x equals negative 13 divided by negative 3. I get 13 over 3. If you don't like it as a fraction, we can make it approximately a decimal. I think it's about 4.3. Let's see. Okay, so that was my x-intercept. And then remember our y-intercept, or sorry, not our y-intercept. We don't care about y. We care about our vertical asymptote, and that's the denominator. So I'm going to set the denominator equal to 0 now. So to find my VA, I do x minus 3 equals 0. Add 3 to both sides, x equals 3. So these are now my points of interest that I'm going to go put on my graph, my little number line. I'll come back to this in a second, but if you remember from earlier, we took all of our x-intercepts, all of our solutions, all of our zeros from all the problems above, so 2, 3/2, 4, and we plug them in to our sign chart and we put it on our number line. Same idea over here, but now we're going to do our vertical asymptote as well. So my number line only has two things. It only has 3 and 4.3, or that 13/3. Just like we were doing before, we need to make sure that we're checking all of the numbers in the interval. So I just need a number somewhere in the interval. So like a number that's smaller than 3 is 0. A number that's between 3 and then 4.3 would be 4. And then a number bigger than 4.3 is 5. Again, any number in those intervals works. There's no right or wrong answer. And then we make our sign chart. Got 0, 4, and 5. And then you might be like, okay, well, I got this side, but like, what do I write up on top? We write all of the factors of what was my rational function. So in this case, you've got one column that will have the numerator, and then we'll have one column that has the denominator. If there were multiple parts, we'd have as many columns for those parts. So I've got a column that's going to say negative 3x plus 13. And then I'm going to have one that says x minus 3. And then the last one will be all of it together. Okay, let's start by plugging in and then we'll see why this works. So if I have 0 and I plug it in and I do, all right, negative 3 times 0 is 0. 0 plus 13, oh, that will be a positive number. Then I do 0 minus 3, that's a negative number. All right, now my question, or your question to me might be like, okay, well, how do we find what goes in the last column? Just like when we were doing with polynomials, we were multiplying them together. We were like, okay, well, a positive times a negative, well, we know that would end up being a negative number. We were multiplying them together. We're doing the same idea now, but instead of multiplying, we're dividing. A positive divided by a negative, well, that acts the same way as if we were multiplying. If they are opposite signs, or if you have like, if you don't have a pair of negatives, then it will stay negative. So a positive divided by a negative will stay negative. So that's how I find those final signs. We'll do the next one and see how it works too. 4 times negative 3 is negative 12. Negative 12 plus 13, oh, that's positive. And then 4 minus 3, oh, that's also positive. This time I'm doing a positive divided by a positive. Well, a positive divided by a positive stays positive. And then I've got 5. So 5 times negative 3 is negative 15, plus 13 is still negative, and then 5 minus 3 is a positive number. So now I've got a negative divided by a positive. Negative divided by positive stays negative. Once we fill in our sign chart, go put your signs on your number line. So just a reminder of everything I've done. First thing I had to do is manipulate my equation to get everything in one fraction. Once I got it in one fraction, I was able to identify the x-intercept and the vertical asymptote because those are points of interest. Then I graphed those on my number line, and then I checked numbers in those intervals to see what the sign would be, what the y would be. Now that I have that, I'm ready to finally solve. It says we want the interval where the function is less than 0. So if I'm going to do less than 0, I care about this interval right here and this interval right here. So I'm going to write f of x is less than 0, and that's on the interval from negative infinity to 3, parentheses, because it's a less than. And then it's also from, you can either write 4.3 Or you can write 13 over 3. It does not matter to me. They're the same number, comma, positive infinity. Good. Remember, all my answers have been interval. So if you're not getting an interval, you're doing something wrong. I'm going to prove this on the calculator. So does anyone have any questions before I jump to the calculator? My one thing is if I say solve like by hand, then that means I want to see all of these steps. I want to see a number line. I want to see a sign chart. If you just went like from the equation to this, then you would miss points because you're not showing me all the steps you need. If I say use a calculator, you can go directly there. But since this doesn't say that, we don't get to do that. So that's why I'm showing you all the steps. But I do want to prove my point with the calculator. So here's my calculator. And I'm going to put in this final equation. So we at least should have gotten to that final equation if we were going to put it in the calculator. So I'm going to do negative 3x plus 13 divided by x minus 3. Something about me is I don't know if my calculator is just that much older than most of yours, but I'm very careful about putting parentheses in here because I'm afraid if I don't, then it will take it as like just 13 divided by just x, and that's not what I want. I want the whole numerator divided by the whole denominator. So just make sure that it's represented that way on your calculator. Sometimes I have students that want to play with like the equal sign and make it like a less than. That's not what we're doing here. Or like, I don't know where you play with it, but maybe on your fancy calculator, you can make this a less than. That's not like a thing we do here. So don't do anything crazy like that. I'm going to go to normal Zoom. I was doing word problems earlier, so those were like crazy windows. So I'm just at a standard window, and then this is the graph I get. I'm going to sketch it on here just so I can draw on it. Something like that. Okay. So I don't know if you can see my graph looks something like what the calculator has. I said in class yesterday, I was like, you can graph it to see if it makes sense. And then I just moved on and a couple kids were confused on like, how do I know it makes sense? Remember that we were asking for where is it less than 0? And my sign chart tells me where it's less than or greater than 0. And when I say it is less than or greater than, I mean the function or the y's. So I'm essentially looking at my y-axis to see if I'm in the negative y area or if I'm in the positive y area. What my sign chart told me is that I should be in the negative y's anywhere less than 3 and anywhere bigger than 4.3. And then I was only positive between 3 and 4.3. So if I'm looking at this little graph, the positive y's are up here, bigger than 0, and the negative y's are down here, less than 0. So I can see that my graph is negative, 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 negative until I get to this 3 spot. And then it's only positive for the short amount of time right here before it goes through the x-axis and then becomes negative again. So that's what I mean by like checking your work, or if I told you just to put it in the calculator and solve, less than is below the x-axis and greater than is above the x-axis. So that's what I'm talking about when I'm talking about negative and positive. Does that, anybody have any questions on that? Okay, we're gonna do another one similar to this. So hopefully if you have any questions, we'll clear it up. So I'm moving on to number 8. Very same idea, we're doing the exact same process. It looks like everything's already on one side. So again, you are not going to clear the denominator out. You're gonna make those two separate fractions into one big fraction. So go ahead, start that. I'll join you in 1 second. So for anyone who's joining me or was like completely lost and didn't know what to do, first thing I did was I got like denominator. So I multiplied the whole first fraction by x minus 1, and then I multiplied the whole second fraction by x plus 3. And then now I'm going to distribute. I am not going to distribute the denominator, and I'm going to show you why in a second. I'm just going to move things around on the top and combine like terms. So I've got 5x minus 5 plus 3x plus 9 over x minus 1, x plus 3, less than 0. Combine my like terms. 5x plus 3x is 8x. Negative 5 plus 9 is plus 4. All right, so the reason I did not distribute it or FOIL in the denominator is because, like we did on the last problem, I want to find my x-intercept, which is my numerator, and I want to find my VA, which is my denominator. So if my denominator was like FOILed out, I'd have to like factor it back, which is just an extra step. So I don't want to do that. I'm going to keep it in this form. So now I can just set each of them equal to 0. Set each of my factors equal to 0 to find my vertical asymptote. Wow, none of my words are right today. I'm so sorry, guys. X plus 1, x minus 3. X-intercept is my numerator equal to 0. So I've got 8x plus 4 equals 0. Minus 4, I get 8x equals negative 4. And so x equals negative 1/2. The whole reason I found these is so I can put them on my number line. So let's do our number line. Negative 3, negative 1/2, positive 1. Now we got to guess some numbers. So we'll do, I guess, negative 4, negative 1, 0, and 2. And those just feel like easy numbers for me to do. Anybody have any questions so far? Okay, now I'm going to do my sign chart. Put it here. I've got negative 4, negative 1, 0, and 2. And then again, I'm going to do all of my factors over here. So I'm going to have a column for 8x plus 4. I'm going to have a column for x minus 1, and then a column for x plus 3. And then now we check. Negative 4 times 8 would be negative 32 plus 4. Oh, that would still be negative. Negative 4 minus 1, still negative. And then negative 4 plus 3 is still negative as well. Again, if it helps you, you can set up a little like sign chart over here for us to check. So I've got negative, negative, negative. Well, 2 of the negatives will become positive, but then that third negative keeps it negative. Now negative 1, so negative 1 times 8 is negative 8 plus 4 is still negative. Negative 1 minus 1 is still negative, and then negative 1 plus 3 is positive. So now I've got 2 negatives and a positive. Well, that becomes positive because the 2 negatives become positive times another positive stays positive. Now I've got 0. 0 times 8 is 0 plus 4 is positive. 0 minus 1 is negative, and then 0 plus 3 is positive. So now I've got a positive, negative, and a positive, so that goes negative because the one negative keeps it negative. And then now I have 2. 2 times 8 plus 4 will be positive. 2 minus 1 is positive. 2 plus 3 is positive. So all three are positive. When all three are positive, then the last one's also positive. Any questions so far? Okay, I'm gonna put my signs in my number line. Negative, positive, negative, positive. And this time it asked us, oh, it said less than 0 again. So I'm doing f of x is less than 0. And I care about this interval from 0 to -3, and this interval from -1/2 to 1. All right, again, on the two problems we've done today, we had to get the fractions or all the pieces, I guess, of the equation into one big fraction, and we simplified that as much as possible. Then we found our x-intercept and our vertical asymptote. Then we put that on our number line. We used our number line to check our signs, and then our signs told us which intervals gave us negative y's or positive y's. And then we wrote our final answer. Any questions? Any concerns?
Well, we have like one of these, like the fraction ones to do on the calculator.
Probably not. I think the ones on the calculator are more the polynomial ones, so that's a good question. All right, any other questions? All right, we got 2 word problems, and these are both calculator problems. The first one should be a nice little reminder. We've done this type of problem before. You're welcome to go get your calculator if you need it, or you can just watch me do it. Again, this is being recorded, so you can always go back and watch me do the little strokes through the calculator if that helps. So number 9, the second to last problem on this page, is talking about this packing company that is designing a box with the volume of at least 600 inches cubed. And squares are going to be cut from the corners of a 20 by 25 inch piece of cardboard with flaps folded up to make an open box. Ooh, open box. We've done those before. We got a big rectangle. We're taking little corner chunks out that are x by x. This is like the 3rd time we've done a box problem, it feels like. Remember I stood in front of you and I like cut the corners out and was like all dramatic. There was paper all over the floor. This is, as long as you remember the like general form, these are not that difficult of problems, I think. And I want us to talk about kind of like the window, because that's what usually gets people all messed up. One of the sides is 20 and the other one is 25. And so if it says it has a volume, that means that I'm going to be dealing with volume. Volume of a like rectangular prism, I guess is the best name for this, is length times width times height. And then we know our height is our x because that's what we cut out, and then we're folding it up to be x high. And then my length and my width come from my what was cut out of. So if one side was 20 and I cut an x off of both sides, I'm left with 20 minus 2x. And then if my other side was 25, and again, I cut an x off of each side, I'm left with 25 minus 2x. Is there some bells? Remember this? Okay, good. And then the only other piece of information we need is the 600 inches. So it's going to be not set equal, it's going to be an inequality. So if it says it's at least 600 inches, then I want like more, right? If I don't remember exactly what at least means, sometimes I put it in terms of like something we're used to. So like if you want at least a 90 on this test, then you'll be happy with a 90 or bigger, right? So I want the volume to be at least 600 or bigger. I guess at least means or equal to, so I'll put an or equal to underneath it. All right, cool. That's all the algebra we're doing. Now I'm going to plug this into my y1 and I'm going to plug this into my y2. We're going to find the intersection. The graph will look something like this. And then we just want to find the interval where 600 intersects it. And since I want it to be that or bigger, we'll want like this area right here. This is something that I think is really important to practice plugging in and finding on your own too, because I know that like, I'm always like, oh, it's just a calculator problem. I'm sure I can replicate that on a test. But then you like get to the test and you're like, ah, shoot, what was it again? How do I do this? Blah, blah, blah. So don't be afraid to practice these on your own. I've got x, I've got 20 minus 2x, and I've got 25 minus 2x. All right, now my window is going to be kind of funny. So let's click on the window. We know that we can't have a negative amount that we're cutting off, and we know that we can't have negative volume. So both of my mins are going to be 0. Now, we remember our max x is based on our smallest size. So remember I used to ask you for domain. I'd be like, what's the domain here? The domain, or my like biggest x value I'm going to get, is the smallest side divided by 2. So I'm actually going to keep my x max here at 10 because 20 divided by 2 is 10. There's no way for us to cut more than 10 off of both sides, because then we're going to come to a place that like we just physically cannot cut any more off. For my y's though, I got to use some context clues. Since it says that the volume we want to be at least 600, well then I need to go to at least 600 on my x max. I'm probably going to go a little bit bigger. I am probably going to try 1,000. I'm nervous if I only did like 700 or 800, I wouldn't get the whole graph. So if I go all the way to 1,000, I'm like almost positive I'm going to see it all. And then if I don't, then I'll see most of it, I would think. It's again, I guess, and check on the window, but a lot of it's like there's a logical reasoning behind it. So it's not completely just arbitrary numbers. We do have a reason for it. So now I graph it. Oh, very nice. Oh, I forgot my 600. Okay, don't forget your 600 like I did. 600 goes in your y2. I told you guys to do that and I didn't do it. There we go. Now I have two curves. I've got my blue curve and then I've got my red straight line. So we want to find the intersection between them. Intersect. I'm gonna find the first one. So my first point of intersection is at 1.66, it looks like. And then my second point of intersection is 6.16. Okay. And then again, we said we wanted at least, which means that we want all of these numbers that are above 600. If it's below 600, that doesn't fit what I want, but all of the numbers that are bigger than 1.66 and 6.16, those are all okay. So when I jump back over here to my page, my answer is again an interval. All of the answers on this sheet are an interval. So I've got 1.66 with my bracket, and I've got 6.16, also a bracket. That's it. Any questions on that one? We did a good job with the box pictures before, so it should be kind of gimme points right there. All right, last one. This is also similar to what we've done before, but it's a little bit different because I'm stretching us a little bit. This time we've done problems like this with area and perimeter. So like I'd say like the area has to be blah, blah, blah. And then we want the perimeter to be at least this, or the perimeter is this, and we want the area to be at most blah, blah, blah. So I gave you those things and we'd solve for like my width and then plug that in here and then go from there to solve for like the length or whatever, one of the other variables. This time we're doing a cylinder can, And so we're looking at the volume of a cylinder can and the surface area of a cylinder can. Now, I had to look up those formulas, and if I had to look them up, I assume you would also have to look them up. So if this was something I would do on a quiz or a test, I would put them on here, because the whole thing I'm testing you on is not, do you know the volume of a cylinder? You're gonna make it plenty far in life without knowing that off the top of your head. But what I am expecting you to know is like the concept of like plugging an equation into something else or finding the max on the calculator. So that's this. The formulas is not the skill I'm testing on. Everything else is the skill, so I would give you this. Volume generally for a cylinder can is V equals pi r squared h. And then surface area generally is 2 pi r h plus 2 pi r squared. All right, we need these because it says find the radius and the height of the cans. It tells us what we want the volume to be. We want the volume to be 2,000, and we want the surface area to be less than 1,000. Okay, so that being said, we can rewrite a couple things. I can know that the volume has to equal this 2,000. So 2,000 equals pi r squared h. We know surface area, it has to be at a less than, that's less than 1,000. Technically, since I gave you a number for both of them, you have a little bit more of a choice in like when I say maximum area and then you don't have a choice. However, I would never solve with an inequality because that's not exact enough. We want to solve the one with the equal sign. It doesn't matter which variable we solve for, we just want to solve for what's easiest. And in this case, if one of my variables has a square and the other one doesn't, well, the one that doesn't have the square is the easiest one to solve for. It's the easiest one to get all by itself. So I can very easily get h all by itself by dividing by pi r squared from both sides. These cancel. I don't need this left side to cancel. It can still be 2,000 over pi r squared equals h. Now, the whole reason that's helpful is now I'm going to replace h, which was a variable, with this expression, 2,000 divided by pi r squared, because there's already r's in that other formula. So it's going to be super easy to just replace h with this expression with r, and then I'm going to be able to solve, or even better, I'm going to put it in the calculator and have it solve it for me. So I have 2 pi r and instead of h, I'm writing this 2,000 over pi r squared. Everything else stayed the same. I am going to clean it up a little bit before I put it in the calculator because I don't want it, I don't want to, you know, type in A, so many letters, and then B, I don't want to mess something up and then like not know how to fix it. So the only thing I can really do is simplify this like most left side. I can cross out the pi's on both of these. The pi's go away. And then the r cancels with one of the r's in the denominator. Again, you can think of this as 2 pi r over 1. So then I get to multiply 2 and 2,000 to get 4,000, and then now I only have one r in the denominator. This is as simple as I want to keep it. I'm going to put this in the y1, and I'm going to put 1,000 in the y2, and then we're going to graph them and find their intersection. Keep that up so you can see it. Excuse me. Okay, y equals, that becomes 1,000. And then this, again, I like to use parentheses, so if you feel confident without, go for it. I'm just very cautious. Don't forget you can find pi by going second caret the button under clear, and it gives you pi. And I want you to use pi, not 3.14. And then x squared. Again, we're gonna have to play with our window a little bit. In this case, my window, again, it can't go lower than 0. So both my mins should be 0. Let's see, mins are 0. Max, I need to hit 1,000. So I'll probably try and go to 2,000 just so I can ensure that I see everything. Oh, that's too many. And then for X max, I honestly don't know. I have no idea what my X's could be. I'm gonna guess it's less than 20. It might be like a lot less than 20. It might be like right at 20. There's really no reasoning behind that guess. I really have no idea what the R could be. So I'm assuming it can't be so big. I'm gonna keep it kind of small, and if I need to adjust, I will. So I'm gonna graph this now. Oh, and I see plenty. It says we want the function to be less than in 1,000. So when it's less than or lower than 1,000, it's just this little piece right here. So again, we're just gonna find the intersections, and we're gonna do the area or the interval between those intersections because it's lower than, it's less than. So again, let's second trace, intersect. I go close to the first point so I don't have to go out of order. 4.62. And then second trace, other intersect. 9.65. It said less than, not less than or equal to, so I'm putting parentheses around all of that. And again, all my answers were intervals, so that is my interval. So just a review of everything we've done today, we did 2 rational equation problems with the intervals where we did our number line and sign chart to find the interval. And then we did 2 word problems, which I think are similar to ones that we've done before, but we just reminded ourselves how they go in the calculator, how to write the interval, that we need to write an interval. And so now we've got a couple examples done. Any questions on the notes?
When it asks, it's asking like find the radius and the height, so we don't have to put the height into terms of like actual numbers. We can just use 2,000 over pi r squared.
So I guess technically I would put like marks for like height and radius because this is your radius. For height, we would plug, I guess, both of these numbers in for r there and then solve. But since it's an interval, I'm okay with just leaving it here for the r. If I want both, I'll make sure it's really obvious. Any other questions? Okay, I'm gonna stop share. I'm gonna stop record probably too.